Yeah, we will get started in maybe 2 minutes.
Sounds good.
Make sure everybody is on. Yeah, Suresh, I actually added the agenda slide also there if you want to display that.
Okay, sounds good. Meet Echo is not picking it up, so I'll just share on the screen. Yari.
Hello, good afternoon.
Hey, Marisol. Gary, do you see the screen?
Yes, we see
Yeah.
the note.
Yeah, and it's 3 past, so I think we can get going.
Okay, cool. Go ahead, get started, Gary.
Yeah, so welcome again today for the second session, and please mind the IETF note well. There's some rules regarding various things, how you behave yourself in the IETF, whether it's about IPRs or code of conduct and so on. So please be familiar with these things. I'm going to go into detail of that today, but be aware. And today's agenda then has, basically 4 main items, and then we have some discussion of the next steps and close the meeting. Any agenda bashing at this point, or are we missing anything here?
I just got a note from Carlos like a few minutes ago that he may not be able to make it. So like I'll just like try to push like Carlos's message. I think I sent it to you as well, Yari, just a few minutes before. So we can probably push Carlos further down the meeting if you can, to see if you can make it.
Hi, this is Giuseppe. If Carlos will not attend, I can present because I'm
Okay.
one of the authors, so I can do that.
Oh, excellent, Giuseppe. Thank you. Like, yeah, then
Good.
it's good. Yeah, perfect. Thank you.
Yeah, well.
Thanks. Okay, then we're good, Yari.
Yeah, so I think then we go towards the sustainability and hotspots, and Ali.
Yeah.
Thanks,
Ali,
Emma.
let me load the slides and I'll give you control, okay?
Okay, great. Thank you.
And thanks, Carson. I think this works much better than the requesting slides.
Perfect. Thanks so much. Good afternoon, good morning, good evening. Today, I want to, let's say, present a bit more focused perspective on this wider sustainability impact topic, namely where and what to focus on first and foremost. It's a personal perspective, of course, and it's open to discussion. Basically, from a broader view, how can we narrow it down to some more concrete action and focus? First, I want to take stock of some sound industry assessments on the ICT sector, energy consumption and GHG emissions, the status quo. And for that, I want to share two, let's say, data-oriented references. One of them have been, let's say, reviewed in the E-Impact mailing list already from our colleagues, Jens, Nina, Pernilla, and Doug. This is related to the ICT sector, electricity consumption and greenhouse gas emissions based on a wide data set from company reporting as well as some indicators our colleagues have worked out. And also on a World Bank and ITU report on measuring the emissions and energy footprint of the ICT sector. These are organizations that have had a long history of data-centric decision-making, analysis, and science-based targets. So ITU have developed several standards based on let's say, these science-based initiatives in collaboration with, for example, the International Energy Agency, which is also a key reference when it comes to energy GHG emissions. So out of these data sets, let's say, what are the few messages or takeaways we can have? And one of them is in 2020, the ICT sector used about 4% of the global electricity and emitted about 1.4% of GHGs, of the global total, which might seem minor in comparison to other sectors like transport, energy generation, or let's say the agriculture sectors. Of these ICT sector emissions, percent-wise, the tendency is to follow the global trend. Basically, it is somewhat increasing and not decreasing, certainly not decreasing, which is somewhat, as we will see, off track. A good news is that ICT sector has a relatively good renewable energy use. Out of our total energy consumption, we are aware of the carbon intensity and many operators, especially in the global north, are using renewable energy to a wide extent. Electricity consumption and GHG emissions are not aligned with data growth rates. This is another observation. Essentially, this has been a discussion point in the mailing list as well, the energy proportionality, and we don't observe this. Basically, we cannot make a correlation that data on networks or ICT handling data volumes has a direct impact on electricity use or GHG emissions. This is not correlated. That's the observation from these two references as well. If we go further, there is a distinction, let's say, in standards as well, of different domains in the ICT sector. Basically, there are the user equipment, the access network, the operator activities that are run in parallel to operating the network. There is the global internet, and then, of course, there is the enterprise networks, which together form the ICT sector as ITU defines it. And then there is the entertainment and media sector, which includes the TVs, the papers, etc. If we look at this picture and try to understand which domain is responsible for most of the, let's say, GHG emissions, user devices, by and large, take up about 57% of the sector GHG emissions. So user equipment is responsible. Out of its manufacturing, its charging, and its operation of the 57% of the GHG emissions. And this is divided roughly 50-50 between the use phase and the embodied emissions. Roughly speaking, embodied emissions means the GHG impact during the manufacturing of the devices, user devices. And the use phase is when they are operational, how much impact they create. Networks, on the other hand, mobile and fixed, including the core as well, core is included in the fixed domain, take up about 24%, 1/4 of the, let's say, ICT domain's GHG emissions. Different from the user devices, the network impact is 83% in the use phase. Basically, the manufacturing embodied emissions is rather small at this stage, which is 17%. And most of it is in the use phase, which gives us an indicator why we have to focus mostly on or primarily on the use phase, the operational phase of the networks. Data centers and enterprise networks are reported together, and they are about 18% of the global ICT GHG emissions. And similar to networks, they are 78% in use phase and 22% in embodied emissions. So this is the, let's say, general outlook from domain perspective in the network. And per subscriber energy consumption, either fixed, mobile, is stable, while emissions tend to decrease due to renewable energy use. This, we will come back to these when we try to determine where we can have the most impact. But let's remember, user devices have a huge impact, and networks have most of their impact in the use phase. Now, share of ICTs in the global GHG emissions is small. Why then should we still care? We hear this very often. We are not a global problem. We are just a small piece of the puzzle. But why? Why should we still work on energy efficiency, energy consumption reductions, or circularity? Why does it matter? Now, there have been two global standards developed to answer this question. ITU-T L1470, which describes trajectories, and L1471, how to reach net zero in ICT. And why have these been developed? We are all familiar with the Paris Agreement that sets the conditions, targets for keeping global warming to 1.5 degrees C. And as a global, let's say, community, we are, of course, all of humanity is, of course, and the ICT sector is in parallel, of course, to reach the Paris Agreement goals. To reach the goals, basically ITUT, working with many organizations, have developed these trajectories, and they have identified that by 2030, ICT sector must halve its emissions. Basically, today, it's not changing. And by 2030, it must be halved to meet the Paris Agreement goals in our own domain. Additionally, most ICT organizations have net zero pledges. Our companies, many organizations, universities, governments, countries, they all pledge to net zero targets. And they are expected to report on them year on year. And more than expectations, soon there will be requirements coming from regulation. And renewable energy transition is, of course, a fundamental component in this picture, but this transition by 2030 is not projected to make up for the delta in the trajectories. We cannot rely on the new renewable energy availability to meet the targets. So we have to reduce our emissions. In addition to that, currently 1/3 of the world population remain unconnected to the internet. To connect them with adequate infrastructure to provide the, let's say, required services that the other 2/3 of the world population currently enjoy, we must invest in huge infrastructure expansion. And this has to be done in a sustainable way. Of course, subscriber numbers can grow, and their per subscriber energy use is currently stable, but as the numbers grow, this also adds and complicates the whole equation. And in addition to that, when lots of companies talk about the upsides, ICT sector is indeed fueling new trends like the digital twins, the metaverse, or pervasive use of AI, and all of which might increase digitalization dramatically. Basically, the equations can change from now towards 2030, not for the better. So we have to do something. And what's that supposed to be? These standards that I shared also give some guidance. Now, the first thing to do is this metaphor of the bathtub. Basically, the atmosphere is depicted as a bathtub, and we have to ensure that the bathtub doesn't overflow. And the first thing we have to do is to avoid that the bathtub in our house overflows. And incidentally, here is a, let's say, line that you see on the bathtub pre-industrial levels of atmosphere carbon content. And in 1870, pre-industrial switches to industrial. And this is called the technological revolution, or the second industrial revolution. Basically, the electrical power and telephony introduction to the global stage, which is essentially the start of our industry. And from then on, we have added 970 gigatons of CO2 into the atmosphere. And then, as the Paris Agreement indicates, the bathtub levels are drawn here, 1 degree, 1.5, and 2. We're already past 1, and for 1.5, there is little room left. And we have to ensure that the emissions that we add to the atmosphere are reduced and the removals are, let's say, magnified. But atmospheric sinks, as they are called, which are the carbon offset mechanisms, as we know, are rather controversial, and they don't make up for the GHG emission reduction measures. So we cannot be complacent and say there will be carbon sinks and will be okay. There are some rules and responsible use methodologies for that. Now, given this is telling the carbon side of the story. What else can we do? We have to also remember that the ICT footprint covers more than GHG emissions. We have heard this a couple of times before, but what does it mean for the sector? Basically, land, water, materials use, as well as biodiversity loss are also pushing the planet to its limits. And we are now well informed that these limits can impact one another, and the cascade effects can also create feedback loops to the climate, as biodiversity loss or let's say deforestation mean carbon sinks, forests can turn into emission sources. So we have to be mindful of that. But what does it mean in terms of ICT? It means that materials efficiency and circularity also matter, as well as how these are sourced. We have to be mindful of land use, pollutions, species extinction, and ecosystem degradation. Also, ICTs and internet, being in global supply chains everywhere today, punch above their weight when it comes to global sustainability. So this is the enablement effect. ICTs can help decarbonize other sectors, as well as help in adapting to the already occurring climate change impacts. So this is the resilience building activity. These are, of course, general statements, but more specifically, what do they mean for us? Reducing energy use is the primary, let's say, mechanism we have, which is tied to GHG emissions, of course. Reducing energy consumption in both the production and use phases, increasing energy efficiency, energy savings, and energy proportionality. This is our primary item. This is given in standards 1470 and 71 as well. I am not inventing them. Second is being part of the renewable energy transition in our use, but also helping other sectors use more renewable energy. This is the second goal. The third one is encouraging carbon awareness in end users. As we have seen, user equipment and usage, basically consumption, has the biggest GHG emissions in our sector. So anything we can do for carbon awareness and hopefully reduction measures in end users is mostly appreciated. Then comes the circular economy principles. Basically, reuse of network equipment, eco-design principles, building repairable products, prolonging product and service lifetimes, and optimizing the end-of-life treatment. Basically, refurbishing equipment, pushing it from the core to the edges if possible, recycling, and minimizing our waste. We can also manage our supply chain with sustainable sourcing and responsible use of GHG removal mechanisms. Basically, there are guidelines on what you can account comfortably into, let's say, your net zero calculations as, let's say, you plant trees, but you still, let's say, emit a lot of GHG. That's not counted as a responsible use of the offsetting mechanisms. There is a definition that it has to be somewhat in the same sector. Enabling avoided emissions is also a target, which is the handprint activities. And focusing on standardized methodology, data, monitoring, and reporting, as we have heard yesterday. These are things that the ICT sector has to move on. But okay, isn't this all about either hardware or applications? What do internet working protocols and IETF have to do with all of this? This is in the back of our minds all the time. What can the IETF do? What can protocol designers do to meet the ICT action items? Now, of course, everyone has to reach this answer by themselves, but I can provide some pointers. In protocol design, I'm going to ask some questions, and based on that, you can decide. In protocol design, have you come across the following trade-offs? Performance versus resource use, memory, processor cycles, the bandwidth. If you have faced this trade-off, then you have probably had an impact on sustainability, positive or negative. Have you had a clean slate approach versus backwards compatibility? That's also a trade-off. If you sacrificed backwards compatibility, then you probably had an impact on hardware and also user equipment potentially. That might have had an impact. Centralized versus distributed architectures, and dedicated hardware use versus cloudification, virtualization. There are a number of moving parts here, but generally speaking, centralization usually does not lead to much sustainability. There are, of course, arguments, but this is the current thinking. This is one of my favorites, relying on hardware being always ready and available for keep alive messages, hot redundancy, or resilience versus sleep modes, module shutdowns. So this is also impacting if hardware can implement sleep modes. Then time to deliver versus modular, clean design and simplicity. We have all faced that when there is time pressure, we might cut corners. That also has an impact on sustainability. So if you said yes to any of this, you probably had an impact on sustainability. In protocol design, then have you faced these challenges? Implementation of nice-to-have features, triggering of more energy or resource use, or less efficiency in end-user devices, or introduction of complexity or more capacity requirements in data center operations, creation of APIs or data models that trigger heavier resource use at the application layers, polling versus, let's say, interrupt-driven solutions, introduction of new parameters that affect the data path or the extension of the length of existing ones. One of my, let's say, examples here is encryption key sizes. Let's say a protocol design upgrade requires that you double the length of the key. And what does it mean for the existing hardware? Can it cope for providing the encryption at line rate? That's a question. If you say yes, you probably had an impact on sustainability. Now, also, if you haven't taken on board some of these principles, you might also have had an impact on sustainability. Investing enough in statistics, explainability, and transparency, ensuring that implementations can scale Basically, if you change something in a protocol or you develop a feature that has to be, let's say, implemented by upgrading all the nodes in the network, that has a big impact. Supporting serviceability and upgradability, also being mindful of minimum system requirements. And there are also these were some concrete examples, but there are also the intangible ones that rely on your assessment as an expert. Did you think that what you're implementing costs more than what it saves with respect to resources or impact? Have you decided to compete instead of collaborating? Have you avoided resource sharing, basically because it was difficult to implement, perhaps? Have you over-engineered a solution or added to its complexity? Have you felt that you are pushing the limits of infrastructure or user resources with your interventions? And have you thought you triggered some overconsumption in the system or in the end users? These are all clues that might highlight that something went wrong or well with respect to sustainability. Then also, all interventions are not equal. We have heard many times that in our careers, we worked for months or years and the impact of what we did was minimal. When it comes to sustainability interventions, this is clearly an important area because we don't have much time. So how do we know we are working on something that will have significant impact towards the, let's say, decarbonization goals and circularity and sustainability in general? I would say that if you're not working on a specific sustainability feature, you're working in a general area or in your specific protocol, and you want to be mindful of sustainability, if you think of the general topics outlined already, then you will pick the low-hanging fruit, basically being mindful of the energy consumption, efficiency, renewable energy, etc. would be, let's say, general targets, but specifically the questions I asked could guide you in more, let's say, sustainable design. But if you are working on sustainability features like we intend to do here, the following should help. Basically, the indicators, the metrics we have been talking about. But I also want to raise this with you. We should not insist on measurements all the time because they are going to be hard to come by and they are going to be, let's say, hard to monitor. We can also work with qualitative and quantitative indicators. Basically, indicators are outcome oriented. Basically, the usage, the operation phase of what you're designing, when it's put to use, can we deduce or infer from certain indicators that what you have done has an impact, specifically for sustainability outcomes? And observing how your implementations, your protocol interventions could change them. Especially important here is that indicators must include deployment and operational aspects, basically. And most of the data that was used in the previous references was based on indicators, not so much measuring in the network. And we should have hardware and supply chain and life cycle impact in mind. Essentially, it doesn't end with what we are doing in the protocol boundary. It is sitting on a supply chain and it has a life cycle. It doesn't also end when you publish the protocol. What think of implementation, think of operation, think of end of life. Always having limits in mind. Where does it lead, your changes, and when should it stop? We have come to this point because we thought there were no limits. Of course, we are an innovation-driven sector, and we want to push the boundaries, but now is the time to think of limits and boundaries. Specifically and systematically, I'm coming to the end, sorry. What can IETF and IRTF systematically do? Since we have the pressing time targets and the boundaries, we need to look back as much as ahead. Basically, internet-working technology is deployed and it's operating, and it takes time to change it. So to create GHG emissions reductions fast, we need to focus on what's running today, what has already been developed by IETF and deployed by vendors, operators, organizations, and we have to provide assessments for that, not necessarily measurements, but assessments. How much it contributes to GHG emissions, and how can we develop mitigation strategies? How can we manage the deployed infrastructure, the operation to reduce GHG emissions? Usage and operational perspectives need to be prioritized so that use phase emissions are reduced as soon as and as much as possible. That's a priority because most of our impact is in the use phase, and we have to prioritize that. Hardware dependencies should and could be handled systematically for circularity considerations, both in the end user data center, but as well as in the network, because they have embedded emissions as well. No matter if small, but they have to, if we have an opportunity, we should not pass by reducing that. Now, we have heard that it is hard to come by to a consensus sometimes, and maybe we can do it in smaller organizations. And my question is, can area directorates, for example, organize audits to capture the low-hanging fruits today in what has been deployed and establish both mitigation strategies, if possible, and guidance for protocol development in the future? We have to do something about what's running today, and we have to mitigate that. Now, for a bit more longer term, what IRTF can do, I think we have to focus on our limits. It's all about knowing and working within our limits. In the sustainability considerations ID, we talked about the donut perspective. Basically, there are boundaries pushing in opposite directions, and they create a donut-shaped space where there is a safe operation zone. We have to understand where is that for our internet working protocols, and we have to understand how we can, let's say, create indicators for that safe zone, the limits. And we have to create baselines and target values for those limits and strive to remain within that zone. This is not easy because of the fact that the links, causality between those limits and what we do in protocols is hard to establish. This is the difficulty we are living through every day when we want to improve our sustainability impact. So IRTF researchers can hopefully help establish that causality to a certain extent. Absolute will not be possible probably, but one consolation is that the computing world has been working on this research for years. As you can see on this, there is the limits conferences, ninth session is being organized this year. So in the internetworking world, we can also think about limits. And also our immediate focus is on GHG emissions, but we have to also take on board the societal and economic perspectives of sustainability. And this is not, let's say, a theory or far-fetched thing, because even if we develop the technology changes for sustainability, their deployment and effectiveness rely on their affordability, acceptability, implementability at societal and economic scales. So that's hopefully a more focused perspective. Thanks very much for listening, and I'm open to questions.
Really, thank you very much. That's very interesting perspective. I do have a question for you. So you said, so there's like one thing we kind of talked about yesterday, right? Like, the gap analysis, like that Yari and I talked about, is like, we're not doing enough to actually do stuff other than measure, right? But without the measurement, how do we actually know we make progress? Because like from your thing, I said like, oh, we don't really. So I don't know if it's like something I'm over assuming, but you're like, oh, let's not focus on the measurements. But I think we still need it, right, to see
yes.
if outcomes have been reached. And the way I was thinking about it is like more look at like what are the right things to measure, right? Like it's kind of how I would phrase it. I think Carsten also had it, right? Looking at like, optimizing for the indicators is not the right thing, but the way to fix it was probably going to pick the right indicators, like whatever would show the progress, right? I think that's probably what we should spend a little bit more time on to see, does it actually make a difference? Because one of the presentations in the workshop was, it's not like, really useful to like reduce the consumption if it's not going over a step function, right? I don't know who it was. I don't know if it was Dom or something. Talked about how the network grows in like steps, and it's like more impactful to avoid stepping up something rather than trying to like reduce the consumption within a step, right? And so have you thought a little bit more about it, like how you phrase it? Thank you.
Absolutely. Thanks, Suresh, for this question. It is indeed a key topic, and we are very used to working with KPIs, key performance indicators, and speed, latency, jitter, bandwidth targets. These are all KPIs which can be, let's say, readily measured, monitored on a local scale. Then we have started working on things called key value indicators. These are sort of outcome oriented. Key performance indicators are technology specific, and we can work on it in the lab. Whereas the key value indicators are those that are measuring the impact of the technology in the, let's say, use phase. And these are starting from the use case definition. Then you define what technology you need. Let's say somehow in the robotic world, you are, let's say, creating a factory floor, and the company comes and says, hey, I need mobility of the robots. Wired connections don't work anymore. Give me something, solve this issue. Then you say the mobility of the robots is an indicator, and to implement that mobility, you start looking at what technology you have to enable. You have to use Wi-Fi or mobile networks, and what are the jitter, latency, KPIs. Then this becomes a one side measurable, the other side is an indicator, the outcome of your technology intervention. That's the distinction. And that's why also it's not always possible to measure the indicator, because quantitatively, basically, because the factory owner might come and say, hey, here is my production line, here is the level of mobility I need, this didn't work, or it wasn't fast enough. It all depends on the expectation of the use case. That's why the word assessment is used instead of measurement. And that's the kind of, let's say, change we might have to live. Also, the discussion in the email list happened on attribution versus consequential activity, and that's related to the step changes. Basically, in the example of someone working from home, switches to, someone working in the office switches to home office, and then he or she claims that, okay, I'm saving this much GHG emissions because I'm not taking the train. But then someone says, look, the train is still running. You didn't save any GHGs. But if 100 people living in that area did the same, and let's say train company realized this and reduced the frequency of the trains, then the outcome would indeed, the consequence of your action would indeed have a positive impact. That's the step change. So it's similar also to our internetworking. As the capacity reaches a certain level, we increase the infrastructure, then we are hit again with this idle power issue and our consumption increases. But if, for example, a lot of sleep modes are implemented and the traffic drops and one node can take up all and the others can be shut down, we lower this. So it's all about also consequences. The indicators handle consequences a bit better than measured parameters.
Perfect. Thank you. Carlos?
Thank you.
Yeah, thanks a lot, Ali. So you were just giving an interesting example where I don't remember that you explained how you would capture that in the presentation in before, right? So in terms of that you know, I'm building out using a lot more energy with this network to do more video conference, and it looks initially bad, but ultimately, you know, it turns out to be saving more trains, right? So how did you capture that in the metrics or so in before in the presentation? Because I must have missed that.
No, it's okay. This was also captured in the initial E-Impact kickoff in Prague. There is a process from ITU L1480. Basically, that's how you assess impact. You draw a baseline of a process. Let's say what the impact, GHG impact of a worker, let's say. And then you apply a solution. So home office, that has to include both negative and positive impacts. So deployment of more telecom infrastructure has to be accounted for its footprint. And then the positive, that train travel or combustion engine powered or whatever vehicle use has to be accounted for. So it's like a equation you have to calculate before and after the intervention, and you have to look at the delta. That's the L1480, which is indeed not in this slides, but there is indeed a process to be mindful exactly for the consequence, the outcome, not only attributing certain things like sometimes done in data sheets, but looking at the actual impact.
Right, because this right, okay, so it wasn't in these slides, which is why I was kind of thinking in many of these things where you're starting to use more energy, it's so hard to capture the overall outcome, right? Either because it is replacing some other processes that were using even more energy, or just because you're having a new round of innovation, you're also starting to do it against clean energy, right?
Absolutely.
And
So,
I mean, we're already seeing a lot of excess clean energy in places like Germany or so that they can't even use. So you're almost kind of at the need of putting energy consumption into that to not let it go to waste, right? So that's
Yep.
and I think those things I'm struggling to figure out what's the most simple way to even capture that, right? Because I feel it's all very complex.
It is very complex, and indeed sometimes just smaller scopes cannot handle, and that's why the performance indicators and assessments have to go in parallel. We have to work on our technology, energy efficiency matters everywhere, but we have to also work on the assessment, the impact, the outcome of the technology use. Has it had the global impact we hope it will? Thanks. Okay. All right. Thanks a lot. Suresh, do I have to hand over or?
No, I'm good. I think Giuseppe, I think you're next. Let me throw it up. Okay.
Yeah. Okay. Can I ask to share the slides, or you will?
I'm doing it, Giuseppe. Just give me a second. I'm going to give you control. You have control.
Okay. Thank you. Yeah, this is a new draft that we presented. I'm presenting on behalf of the co-author Carlos, Romain, and I'm Giuseppe, about the benchmarking methodology for power in networking devices. We placed this draft in benchmarking working group. Yeah, what is the background? I guess we all know the reason. So we want to help operators to get an idea of the power drawn by their network, their devices, and also to help vendors to test the energy efficiency of their devices. Benchmarking can serve two related objectives. The first one is assessing which system, which device performs best over a set of well-defined scenarios. The second one is to measure the contribution of subsystems or single devices, single services to the overall performance of the system, the so-called micro benchmark. This is much more complex, but so our draft started to focus on the first objective, so aims to compare the energy efficiency for individual devices. Then we can think about of an extension later or a separate draft, so we can further discuss about the second objective. The draft introduced new terminology, because normally, for who is familiar with benchmarking working group draft, there is always a need to define terminology related to the KPI, the performance metric we want to measure and compare. In particular, we refer to the definition of the energy efficiency ratio that is defined as the throughput forwarded by 1 watt, and is introduced in an ETSI document, in an ETSI standard. So we started from this definition because, we think that is quite useful in this as a starting point, right? So in particular, we have to define the total weighted capacity of the interfaces as the weighted sum of all the interfaces throughputs, and the total weighted power as the weighted sum of the all power calculated for the different traffic loads. So basically we have to consider different traffic loads. M is the number of traffic load levels. So we can consider 100%, 30%, 0%, and the number of traffic load levels also depends on the type of devices we want to benchmark. So we have to model, let's say, the device behavior, and we can decide the traffic load levels. And also we can assign different weighted multiplier for the different traffic load levels. Also, the weighted multiplier depend on the, let's say, the traffic that we expect for that kind of device. So if we apply this kind of formulas, we can calculate the energy efficiency ratio. And of course, a higher energy efficiency ratio corresponds to a better energy efficiency. Why we need to benchmark the energy consumption? Because of course the maximum power drawn by a device does not reflect the real power under a normal workload. So that's why we need to consider different traffic load levels. We introduced this new terminology as described in the previous slide, and we can assign a weight to different traffic load levels. And the choice of the multipliers is also related to the type of devices. For example, we can find in the table an example. So for core equipment, we can consider that the medium let's say for a medium traffic levels is around 30% of the interface, while for edge access device it is around, we can say that is around 10%. So we can argue about that, but it's just to show you how we can model the traffic load of different type of equipment. This is not fixed, it's something that is just an example. So if you are doing a benchmark measurement, you can decide this kind of parameter, so they can be fixed a priori and they can be put in a report in order to show under which conditions the device is benchmarked. For the document, let's say described a very simple, let's say, test environment where we have a tester and a power meter. It's important to mention that the device under test also dissipates heat, and that means that part of the power is used for the actual work of the device, while the rest is dissipated as heat. But the power meter only measures the internal energy consumption of the device. This is something that needs to be highlighted. We also need to benchmark, as I said, the device under different traffic loads, because traffic loads affect the energy consumption of the device. Different traffic loads must be included. Also, interface types, the kind of connector must be clearly specified, because these also affect the energy consumption of the device. So the number of ports used per line card, the aggregate bandwidth that each line card can accommodate, and so on. And also the traffic load must be specified in terms of packet size, packet rates, interpacket delay, because all of these may affect the energy consumption of the devices. The draft define initial tests like the throughput, the base power drawn by the network device. That means that without any traffic load. The power drawn by the device with traffic load. So depending on how many traffic load levels we want to consider. And in the end, we can measure the energy efficiency ratio. This is just an initial proposal, so it's just a 0.0 version, because we wanted to, let's say, start this work and present also in the next IETF at the benchmarking working group session, just to start the discussion. Of course, when we benchmark a device, we also need the reporting format that is also specified in the document with, I already mentioned in the previous slide, part of the parameter that needs to be specified. Okay, as a next steps, we are open for cooperation on that. We welcome comments and suggestions, and we also plan to present it at the benchmarking working group meeting. Hopefully, if we can get a slot during that session. So yeah, thank you for the opportunity to present this initial draft here. And yeah, if you have comments, suggestions, thank you.
Thank you, Giuseppe. Thank you. Anybody have comments on this? Douglas, go ahead.
Yeah, I think the likely next steps would be the power impact of bringing down interfaces or bringing them to different speeds, right? The stuff that the folks from Juniper were showing yesterday as well. And so if we have a redundant network, you can shut down redundancy or bring interfaces on the edge from a gigabit to 100 megabit, right? So those are the typical lowest hanging fruit, what you can do already with existing equipment, right?
Yeah, that's right. Indeed, yeah. I also want to, let's say, we also need to sync with the metrics draft. So I know that there is the OPSAVG metrics draft. So we also need to, sync up about what are the metrics about that. And yeah, of course, the test you mentioned is one of the possible next step. Yeah.
I mean, whatever in the equipment that you're actually you're practically working with specific type of equipments to validate the draft work, or what's your process?
We just started. Unfortunately, my co-authors are not here. I know that Romain from Zurich University started some activity. I personally did not. So, but maybe we can provide further details offline or on the mail list, because I personally didn't start any work on that, but I know that Romain makes some initial tests, and we plan to do more tests later, of course.
Go ahead, Marisol. You're up next.
Thank you. Thank you, Giuseppe, to share. I just wanted to ask the same question as Torles, if you have been testing in different devices or even component, but I was wondering why you have been only selected the throughput as a main weighted value, and there are some references for other parameters, right? How the load of the device, how many line cards are there, how many fans are there, how many PSUs on this iShare, the load share are also important factors for changing the efficiency of the energy used. I was wondering if you are looking to include all those in next releases.
Yeah. It's a good comment, because we consider the throughput and the relation between throughput and power drawn by the device, because we started from the definition from the ETSI standard. So we started from that definition in order to have, let's say, a solid foundation. But this implied that, of course, we can improve and add additional tests. And regarding the test environment, we also mentioned that in BMWG there is a well-known RFC 2544 that define the multi-port configuration for the device. So we also, in the reporting, you also need to specify how many line card, and for each line card, how many interface you are using, the interface type. So different condition must be included, and of course this is also depends on the type of device. So, but yeah, it's something that it's just a 0.0 version, so we have time to further improve and further include much more tests if if needed. Yeah.
Okay. Linking also with the comment from Ali on the assessment, right? We had some conversations about what is running on the device and how to assess that efficiency as well, because it's not the same if you are running securities for a good, right? I believe if you extend to the concept of sustainability, that should be taken into consideration depending on how many features that or functionalities
Are
that
enabled. Yeah.
yeah.
Yeah,
Thank you.
correct. Yeah, this also need to specify if you are activating some feature or not. Of course. Yeah.
Thank you.
Thank you.
Alex, you're up next. Go ahead.
Yes, Giuseppe. One other comment to follow up also on the Teresa's comments regarding the different modes and so forth. I think one thing that might be useful to include actually as part of a benchmarking methodology is also the time that it takes for the transitions. But how long does it take to get something, basically from zero power to the fully powered up, or from one power state to the next, because understanding those time durations is important to know also how well will enable basically schemes that rely on predicting, for instance, what the usage may be in the near future. Basically, many of the schemes do, when do I need to basically take something online or offline or power it down or put it in the saving mode? That will depend actually understanding what those durations are to understand what is safe here. So that's a suggestion maybe to incorporate some of those time aspects, not just the power consumption aspects.
Yeah, this is a very good comment. We also consider that when writing the draft. For this very initial version, we consider the, let's say, RFC 2544 recommendation about the timer, that they give flexibility about the timer and the time duration that need to be reported, must be, let's say, decided a priori. But we can also give some guidance if we see that there is some particular, for example, for some services there is some particular power drawn in a specific way, and we can also give recommendation for that. Yeah, but yeah, it's a good point. Yeah, about the timing. Thank you, Alex.
Thanks, Alex. So Giuseppe, I had a question. I'm not sure if you'll be able to answer or not, but like the weighting of the things to put the whole things together, is it your intent to kind of work towards some kind of standard towards that, or is it up to all users to have different weightings for the things to calculate the whole stuff?
In general, the benchmarking document are informational documents, so it's not about standards. So it's just guidelines for how to do benchmark for power, and I think we can follow the same approach. But of course, we need to consider all the parameters that may be useful to carefully benchmark the power efficiency of devices. So that's why we started this document, because we believe that is an important, let's say, milestone for network operators, for vendors, and we can start from that and further improve. But we need some tests and we need much more. So if you are interested, I mean, not you, Suresh, but in general, if people are interested, we are open to cooperate and to put data and to validate this benchmarking testing. Yeah.
Okay, makes sense. No, my biggest concern is like, if the weights are not kind of standardized across the industry, first of all, the results are not comparable, right? And the second thing is people are going to choose the weights so that they look best. So everybody's going to pick a different set of weights, right? And that's kind of my concern. And I know it's like one step beyond your draft, but I just wanted to know if you gave it some thought. Thanks.
No.
Yari, you're up next.
Yes, so thank you for this. This was super interesting and useful. I think I did have some of the same question marks that Suresh just outlined, but I had a sort of a different question also entirely. It's not what you're targeting directly. So if I understood correctly, what you're trying to develop is a methodology where you can sort of standardize some level at least what type of scenarios we should be looking at and how you measure them and how you can then compare equipment, particularly when the equipment is or a function is sort of ready packaged and like everything is something that you can buy from a vendor basically. But I also had this memory about yesterday we were talking about some of these open source exercises and at the IETF when there's something big going on, let's say new TLS or new transport protocol, we would typically have most of the vendors doing their implementations of that new protocol in the hackathon, doing interrupt testing and so on. Just wondering if you're aware of tooling that would be helpful for kind of these kinds of situations, not that you buy a box and hardware, but you have software and sort of instrumenting the software, the power consumption of the software kind of, or is that essentially the same as measuring it by the clock that took this long and it can pump through this many packets per second and then that's it. And the rest is kind of like hardware packaging and marrying the software with the particular hardware in the vendor's product. But so the question is if we could do something in this hackathon or open source space to help people evaluate their implementations better from a sustainability perspective.
Do you mean to measure the power efficiency of software or particularly in software implementation in the hackathon?
Yep.
Yeah, I think it makes sense. Consider that also in benchmarking working group, there are some recommendation about how to benchmark. I don't know. Virtualized function or so on. So there are already some recommendation on that. So it's something that can be done. So the benchmarking also for power efficiency of software. So this can be an extension for this draft. So as well, probably, of course, the parameters are different. It's something that need to be studied, but of course, it makes totally sense. So yeah.
And if there were any tools, for instance, that one could recommend, and you could share information about such tools and have people start learning to use them. I've had brief look at this, very shallow look, but there are people and companies and even tooling that is kind of focused on sustainability of software or power consumption of software. I wasn't particularly impressed on my brief look that there's something usable there, but if there was, it would be potentially useful. And again, I did not look very deep, so I probably missed all of the useful stuff.
No, I agree.
Thank you.
Thanks,
Carlos.
Yeah, so I got totally derailed while Jerry was asking, because that's certainly very interesting as well. So I think that whenever you're actually using compute CPU type network equipment like software-based routers in the CPU, then you will see a lot more linearity of throughput versus energy consumption. So there is certainly a lot of more optimization that can be done than in the classical hardware devices that have these really bad step functions in them. And I think one of the generic things one would want to measure in the first place is relative to the percentage of CPU utilization, what is the energy utilization, right? Because once you classify a device like that, you don't need to measure the energy every time you're measuring the CPU utilization, right? But you can simply do all the performance testing purely on CPU utilization and have the mapping function back to the energy. So I think that would be one of the basic, CPU-based measurements that you have this, that you define this mapping function from CPU utilization over to energy consumption, right? So I think that would be, when you get into these type of software forwarding devices, an interesting thing, right? Because now you've got a result which is a function, right? With respect to,
Exactly.
yeah.
Yeah, exactly.
We've seen these type of, I think people did present these type of graphs in the past already, I think in the workshop or so.
Yeah, exactly. I didn't put in the slide, but in the, let's say, in the draft, we suggested an initial version of the reporting format, because of course, if you need to benchmark devices, or you have to benchmark different devices in different lab in the same condition, so you need to report everything, also the CPU load, because this will affect the energy, the power drawn by the device. So yeah, all
If you
this
have a typical, right, just to give you an example of the impact, right? If you take a typical x86 CPU-based system, you may, under 0% throughput, run it with, 10 watts of power consumption, and it may go up to, 200, 300 watts in high power consumption at 100%. But then if you use the wonderfully, highest throughput software with DPDK and Polmo driver, it will stay under 300 watts all the time, whether you have traffic through it or not, right? So there are humongous differences based on how things are implemented. Actually, the question I wanted to ask with respect to the output, right? So I was mentioning yesterday that a lot of the initial work of, against any type of results might not be in actual running network equipment, but in planning divisions, right? So, and they would simply want to take numbers that they get from somewhere and put them into analysis systems. So I was wondering, have you folks in BMWG ever defined some standard output format? Because I haven't seen that so far, right? So there are all these wonderful, benchmark methodology and results, but however somebody writes it down where, so I mean standardized XML format also, so that ingesting this data from different devices becomes much easier, right? We do have Yang, but I haven't seen any type of Yang models that are available offline, right? They're all only available if you have a running system from which you can, transfer it through a transport like netconf or so on.
Yeah, this is an interesting point. From what I know, there is no such, let's say, XML and structure for the benchmarking test, but it's something interesting to investigate for the future, of course, because can help a lot the implementers, this kind of systematic and structured information. So we plan to present at the next IETF for the first time, hopefully, if we can get a slot for the next BMWG meeting, and this can be a good point that can be raised. If you have time, please join BMWG. I'm also chairman of the session, and yeah, we can further discuss there. I think it's a good point in any case. Thank you.
Thank you. Yari? Did you want to say something, or was it from your...
Sorry, pass. I need to lower my hand.
Okay, cool. Thank you. Thanks a lot, Giuseppe. Dom, you're up next.
Okay, thank you.
Hey, folks. Hey, how you doing, folks? There's some slides. Awesome presentations, Ali and Giuseppe. Very interesting. Thank you.
Dom, I uploaded your updated slides this morning, and hopefully they'll show up. Like, you know, the Meet Echo, the latest slides are on the data tracker. Meet Echo sometimes takes a delay, and you cannot see. So if you see an issue, kind of like point people to the tracker. Okay.
If I stick to the slides, then I've done it wrong.
That works for me. Thank you. Thanks.
Yeah, so that huge thanks to Suresh and actually Hesham as well for invigorating so much interesting discussion on the E-Impact group. It's always a joy to pick up those emails and get involved. So I'm going to talk a little bit about practical experience of trying to get real-world and real-time energy data from infrastructures that are involved in delivering streaming content at scale. And I think that's got some relevance to the IETF and IETF since streaming applications have become a significant class of internet traffic. So in seeking to understand the energy of streaming, we're inherently needing to understand the energy landscape of the internet. So just a few words of introduction. I've been playing with streaming technology since 1990, actually. Did my first image transfers from the back of a telescope over an IP network called Starlink, which has nothing to do with the modern version of Starlink, and went on to get into moving much faster images than astrophysics photos and putting video online and so on. Spent a lot of time in the early 2000s working actually a little bit with the IETF and others to drive multicast adoption for a CDN that I set up in 2001 in the UK, which was one of the first CDNs, and that's always given me a sort of frontline view of the explosion of streaming traffic over the internet. 2009, I switched to running a software company, which I run today, called Ideas. We deliver software to CDNs, unsurprisingly, and to publishers who are wanting to deliver lots of live video. But in the last few years, as part of my role doing biz dev for that software company, I was organising a number of CDN conferences, and I started asking questions of the architects of Disney and Akamai and Netflix and others that you probably all heard of, what they thought about sustainability and what their strategies were. And to be honest, in 2018, 2019, when we started asking those questions, if I'm really honest, everyone's went, I don't know, the CFO buys the electrons. It's not really our decision. We rely on the telcos and the data centers and the infrastructure underneath us to be doing that right. It's just a function of cost. But as we have sort of become sort of front and center of the media space over the last few years, particularly boosted by the pandemic, the industry has started to feel like the tail that wags the dog of certain parts of the internet. And so we sort of off our own backs taking it as a bit of an initiative to make sure that we're conscious of what we're doing in terms of engineering, and we're aware of the intended and unintended consequences of that engineering through our ecosystems. We engage with the IETF community, particularly through the E-Impact Working Group, and it's a superb group, and I can see many familiar names from that group in the participants room today. Something to note within greening of streaming, there's our members role showing at the bottom there. We have one rule, I think it technically makes us a club, and that is no greenwashing. In effect, it means that we have quite a good peer review process amongst all the working groups and the thinking in those groups, and we try to keep each other honest, basically, and make sure that we're really working towards education and engineering that improves the industry. In terms of scope, this is a diagram I drew up. The top half of this at least is a diagram I drew up just to show how many boxes you need to plug in to get a live stream from an encoder over here on the left through to a set-top box over here on the right, or a mobile phone or whatever it is. Seems to have caused a lot of fascination in the industry, and I've been asked to reproduce that many times. So if you want to have a deeper look at that, then let me know. But I think that's useful for understanding the scope that we think of in streaming. These are all boxes that need to be on in order for our services to get through. And that includes lots of your boxes, I'm sure, through the internet industry. So as we started to try to address this problem, much like presentations earlier today, we want to know where the real world data is. And it's not been easy to find any, to be honest. So the work, just to touch on the work underway inside greening of streaming first, which I think will help you contextualize where our experience with trying to get visibility into operator networks and so on has come from. The group It tries to take a systemic view. Great example in a live stream like the one on my previous diagram. If you reduce the encoding energy from a kilowatt to half a kilowatt, you may be putting 5 watts of extra work on 30 million set-top boxes and put 15 megawatts on the grid or whatever it may be. So we have to understand the interrelationship of all of our technologies and how the decisions we make at certain points in this distribution tree, if you like, actually affect other processes and services. So we're very, very focused on fostering cross-pollination across our working groups and making sure that the working groups don't get siloed. Also, you'll probably notice we talk about energy. We don't really talk about carbon in brutal terms, which probably upset some sustainability-focused people. Engineers don't, certainly in the streaming space, don't really know what carbon is. We don't know how to affect it through our coding decisions. We don't know how to architect around that, but we do have a measurable KPI, which is kilowatt hours or watts, that we can find more often through engineering and start to actually use that as a feedback mechanism as we experiment with new distribution models. We also are not just into putting green inputs into the ecosystem. That's part of the picture, but we have to be good energy citizens as well. It doesn't mean we can just go, it's green, let's build more. Actually, it's better if we've got renewable energy supplies made available for public health or heating homes or whatever it may be, rather than just crunching video encoding and so on. So we set it as an engineering objective amongst our community to make it more efficient regardless. And I think that stands us in good stead. Just to highlight some of our current efforts, the working groups are listed on the right in that sort of mind map tree I've snapshot into the diagram. I won't go into all of them. The three that I think are most important are our pillar working groups, which are 4, 6, and 8. Loosely, they correspond to 6 being compression, preparing your stream, 4 being distribution and getting the stuff through the networks, which will have a lot of touch points here, and working group 8, which is looking at consumer premises equipment, set-top boxes, mobile phones, and so on, and how much energy they really use. There's a lot of, I'll talk about that in a minute, there's a lot of quite loosely based data based on lab and conjecture, or lab and extrapolate, but there isn't a lot of real world data out about there. And in particular in working group 8, we've just been running this week actually in some hackathons, some models where we're putting some smart plugs out into initially internal test groups, but soon hopefully very large test groups, so that we can not test TVs by type, but we can test what type of TVs people have in terms of their energy footprint at scale, and really go and get some real world user measurement from the consumers. That is feeding into our other working groups. I want to just touch base a little bit more about working group 4 specifically, because that touches on the operator space much more. One of the first projects we wanted to understand was there's a fierce debate. It's reared its head lots of times, and I probably fueled that in the impact group, which is about the correlation between traffic and carbon. There's a lot of work had inferred that there was a linear relationship, and that not sending data would somehow not require energy. Well, the graphs on the right show some measurements we took around some major football events, and you can see in a particular rack measurements, you can see some sort of indication of what sort of volatility you get when you have one of the largest traffic spikes. But actually, when you scale that out across all the other racks that weren't being used, that bump was insignificant, and it's really led us to believe that capacity is a much more important benchmark, if you like, than traffic in terms of energy provisioning. Not that there aren't relationships, and especially when you move into our other working groups 6 and 8, there is much more compute going on in the encode and decode space. But in the distribution network and then in the CDN, really at any scale, energy is not really affected directly by traffic. It's affected by capacity. We have a group called the Lesser Chord, which really opens the door to reach out to the engineering community. We reached out to about 20, 30 conferences last year to go directly to engineers and say, regardless of what you've read, where do you think the low-hanging fruit is for directly targeting reducing energy within streaming ecosystems. And the Lesser Accord has done some good work. It's got 2 very active projects and 2 coming active projects, which are looking at areas which we felt the engineering community had go and look here and use their gut feeling as a bellwether. I'll talk a little bit more about this in a second. So what is the landscape? As we've gone knocking on our CDNs and on the telcos underpinning the CDNs and the ISPs that are getting the content out to the consumers and looking for data, we haven't been really able to find very much, not in any in any form that we could consider actionable, real-time, usable data that we could make decisions against. Academia has obviously produced about a decade of really good thinking, but I think if you talk to most people in the academic community, they lack industry reach in terms of industry data. And I would consider our members the industry of certainly a large proportion of traffic delivery, and we're retrofitting that to our sector. This is only a question we started thinking about in the last couple of years. We are just trying to work out where that tooling is. Sort of going back to Giuseppe's presentation, this is a new, a totally new space for us. There is also a bit of a consequence to this correlation between the simplified correlation of gigabytes and carbon. Part of my role within Green and Streaming is to provide a bit of a voice for the industry when regulators are starting to think about how to measure and how to consider energy in the sector. They were already getting quite wed to the linear correlation between gigabytes and carbon, and certainly we were seeing some of the big 5 accountancy firms jumping on that and going, oh, we'll add an ESG report to your quarterlies. And given that telcos have historically reported their profit and their traffic as a sort of hand-in-hand relationship, simply adding a column and going, well, actually, if you're doing that many gigabytes, you're doing this much carbon, so make that your ESG report, has caused an entrenchment problem. There are organisations which are already some way down that path, and I think, heart on hand, our members don't really feel that that's a fair way to correlate ESG reporting with what our activities were. The Lesser Accord activities have brought to the fore a variety of areas, which I'll come back to at the end and sort of throw some points towards where I think the IETF and IRTF might go. But the Lesser Accord projects highlighted from this gut feel from engineers where some obvious areas to go and investigate are peak traffic, peak mitigation may affect capacity planning, forward capacity planning. If you can flatten your peaks using techniques like multicast and so on, better, or peer-to-peer, or just better pre-positioning your content over unicast CDNs and so on, maybe more peaks can be mitigated. Maybe that defers infrastructure. There's some complexities in that as well, because not all infrastructure deferral leads to a better energy profile. The best way to think of that, I think, in short, to keep it short here, is imagine if Amazon's public cloud was running on Pentium 2 processors. I think we'd probably have already passed the climate catastrophe point some years ago. So deferred infrastructure is a complex beast. It's not as simple as simply not doing it. But we need to get actionable data to really get some measurement out about when we do things, what effect does it really have, rather than the conjecture of, well, it works like this in my lab with this bit of kit. If I stick 60 of those out in the field, therefore that's the energy. As we all know, complexity doesn't really work like that. So we're all busy retrofitting the measurement at the moment, and we have, to various extents, managed to run some experiments. I showed you one of the graphs from on the previous slide from one of our big football event measurements, but it's not robust yet. It's not at a point where we're comfortable to share data, which is pretty much isolated to certain test cases in certain environments. That's not good enough to present best practice for an industry yet, from our point of view, but we are working on it. Practical work, both internally and externally. Some thoughts and comments. I think the emphasis, we talked briefly, and Ali stole my thunder a little bit with consequence and attribution. We've talked a little bit about this and a lot on the E-Impact group, and that was a bit of an epiphany. I thank Chris Adams and others for bringing that to the fore in the group. I hadn't really realised that these two issues had become so conflated. and that all the measures and data, some people would use that and talk in attributional model terms, and others would use that and talk in consequential terms. The separation must be made and must be maintained if we're going to focus on, in my mind, making consequential differences. Attribution is fun for saying I'm no longer guilty for the bus's carbon, or no longer guilty for using the internet. But in terms of actually reducing the energy the internet's using, actually reducing our infrastructure's demands, we need to look at the consequences. One of the things I like about these smart plugs is you plug them into the wall and it reduces the energy demand. And if you're measuring that, you are measuring, and you can make improvements as a result of that measurement. You are having a consequential effect. There are not only technical challenges about where we measure, what we measure, and how we analyze that data, how we present that data, and so on. In technical terms, there's also a real challenge at a high level in the presentation of corporate businesses. Greenwashing is a fear. I spoke to the sales group of one of our Blue Chips members a few weeks ago about how they could prompt their sales team to consider sustainability within the sales context. And my message to them was, ultimately, you have to see it as a function of trust. It's better to say we don't know, but we're trying, than it is to say, yes, we're the greenest because here's a made-up data point, which 6 months later gets proven completely wrong, and that scuppers the trust in the relationship. So greenwashing is a complex thing. I don't think much greenwashing is done on purpose. I think most of it is done with noble intent, actually. But the backfire, if it goes wrong, can be complicated. And also, I mentioned this term anti-bragging rights. We have run into some entities who didn't want to participate in tests and measurements because they didn't want to be the big corporation, the big event organizer, or whatever it was, who was the first to be measured. And it would be inevitable, well, you use 3 tons of carbon producing your football game, was obviously going to be something that nobody really wanted to brag about. But at some point, we do have to start that measurement so that we can then iteratively repeat that measurement and see what the trends are. It's not so much that you're the only football game that's ever been mentioned, or the only organization that's ever been mentioned to give a carbon count publicly. It's about the fact that the following quarter or the following year, you took a 20% reduction on it. That's what's really interesting, but it's complicated. It's complicated marketing. It's complicated for corporates to communicate with that sort of data. And we need that data. We need that data to look into classic network considerations. I think we're already thinking about some of those in this group. So we're looking at event energy measurement. That's peaks and load planning. Also, we need to understand about our energy elasticity. We talk about putting devices to sleep, but we don't do it. We talk about having all these different modes of sleep, and we talk at cross purposes about them quite often, but we don't do it. There is very little real implementation of these types of spin down technologies. Telcos and our CDNs are in the business of availability. They would much rather sell the excess availability as an insurance for an SLA or a DDoS attack or security or something than they would spin it down. And so the Jevons paradox kicks in hard in that space. And I think we need to be mindful as an industry about our commercial appetite and our energy appetite. Infrastructure, consequential life cycle assessments and capacity planning. I think we touched on multicast a little bit. It's something I'm very fond of. I'd like to have seen that deployed more widely. We are doing experiments within our own lesser called Project One to get some data to try to look at whether there are energy efficiencies, literally energy efficiencies in using multicast over unicast as part of the commercial picture, as more and more networks are starting to consider certainly multicast ABR technologies as a real means to scale streaming. Redundancy and SLA, I just touched on this with the over provisioning capacity. We found cloud hosts will see a compute spin up for an endpoint on a live stream. They want to offer 4 nines, 5 nines availability to the streaming provider, so they spin up an extra host. Unknown to the streaming operator, the streaming operator then spins up his backup redundancy cloud in another cloud or another AZ or whatever it may be, and the cloud operator doesn't know what they're doing, so they spin up a fourth computer. So we've got 4 computers running. That's a huge amount of over provisioning and redundancy for a stream which may actually have no material value whatsoever, and the users may be quite happy with the odd network buffering. So we are overselling SLA, and that's probably leading to overselling of capacity. And I think we need to review that as a network community. Finally, I would touch on that. One of the other reasons why we need the measurement is we need to know what's going on in the consumer electronic space. I saw the quote actually early on today, and I see it everywhere. There is this idea that the consumer environment is entirely responsible. We can wash our hands of it. Isn't it the silly consumer that bought the set-top box and consumes all the energy? What a shame they want to watch our content. We can't really disown that problem. We make a lot of decisions about what ultimately is on the menu on those devices, both technically and in terms of content. So we have to take ownership of that. We also have to bear in mind that technology is typically only on for a few hours a day. I know this group probably think of CPE to include the router, but the set-top box in our community is typically only on for a few hours a day. And so in the moment of streaming, it may be something that we can measure as having a high energy demand. But actually, when you look at the integral of all the energy through all the infrastructure that's on 24/7, on the off chance that you turn your set-top box on, that probably is disproportionately larger amounts of energy. And I think that's unevaluated at the moment. And we should be cautious about saying it's all in the consumer premises equipment when it comes to energy. Carbon embodied emissions are separate issues, as I mentioned earlier, when you were streaming up, focused on operation energy. So last comment on practical work. Doing measurement in the network is inevitably going to take a long time. You know, we're looking for leadership to some extent to this community. But I would say that overlaying measurement of the network can be simpler, going back to simple £10 devices. You know, for literally a few £1,000s, you can be starting to take a few hundred network points. And that is real data, valuable data, and most of the planning I've seen about how to try to get data in the network back to back to some sort of database you can interrogate seems to look like hundreds of thousands, if not millions of pounds worth of project and developmental work. Whereas for £3,000, you can go and actually start to survey your network almost immediately. So I would encourage this so that we get onto some at least reference real data. Conclusions. Yari and Suresh sort of reminded me to bring this back onto topic specifically for IETF and IRTF. So a few thoughts just to wrap. We clearly need granular actionable data from telcos and cloud providers to even get the conversation with application developers such as the streaming community off on the right path. It may be that regulation can ensure some of that data disclosure. I like to throw this idea out there occasionally. I think it might be as simple, if you really want to start looking at the energy impact, of asking public telcos and public CDN operators to just report their kilowatt hour purchasing on a quarterly basis. It's a really easy piece of data to find everybody. It's at the bottom of your energy bill. And actually, I think that would give analysts a benchmark to follow trends and see whether profitability can be increased while kilowatt hours can be reduced, or at least head towards that in an ideal world. So some technical thought leadership ideas here, which I think are pertinent to IETF and IETF. Keep referring to the layer models. I reflect back on them a lot. They can help scope the engineering ownership of energy efficiency and related up and down reporting in the stack. It's quite, you know, these are complex onion skins, and it's very easy, particularly in the IETF, to feel responsible for everything on the internet. But there's also a sort of microscope, which is you're kind of responsible for the memory state in the routers, the energy holding the memory state in the router, and probably very little else. Everything else is line cards and telco switching and so on. So it's important to scope the limits. And I echo wholeheartedly what Ali said in his presentation earlier. Those limits are absolutely key to actually being able to set yourself achievable goals and so on. Should the IETF be specifying how switches and link layer tech report energy? These are really just some broad questions. I'm not going to offer answers here necessarily, but should application developers be forced down any particular path or be left to evolve their own overlay reporting? But in which case, how do we share visibility of the interrelated IP stack and everything underneath? Is energy measurement an application adjacent to the internet, or is it part of the IP specification? In terms of deployment, it's been impossible to get consensus and momentum around multicast. How do we think we're going to do this with energy if we do start developing protocols? For greening and streaming right now, we're focused in the application space. We're looking for members and partners to scale our real-world testing so we can at least understand the systemic impacts across the streaming supply chain better and focus our work in the right areas. Our model, this testing model I mentioned earlier, is very simple. It's quite brutal, and yet it will provide a real-world reference for future engineering work in our sector. Please do reach out if you can help us scale that particular test up. We'd like to get in touch with people with subscribers and communities that we can go and do tests with. But obviously, we are here to support the IETF and IETF in whatever way we can as a community too. Hopefully that helps, or at least gives some insight into our picture.
Thank you, Dom. Really interesting presentation. I do have like one concrete suggestion for you. So there is this group called MOPS in the IETF, like ops. Like I think like you might find a community, but they may not be exactly into this kind of work, but at least the goal of that is to have a discussion forum for people who do these kind of media operations, right? And that's an interesting place to look at it. And yeah, I don't have a clear solution for you for the hidden redundancy kind of thing, and this happens not just for media but for everything. So I do know that like, there's a whole bunch of replicas like just sitting there and doing stuff, but again, like, you know, going back to like, you know, kind of my original point and like an earlier presentation is that does it create new data centers, or like is it just like something idling, right? Like which is like not taking up that much energy. I think that's the more complex part of the problem, is that like is it actually causing additional stuff, or is it something that would just be idle, like just running another container, right? Like that's something probably you need to dig a little bit more into. But MOPS is my concrete suggestion, like to kind of like talk about this at MOPS and see if it like results in something further.
Yep.
Yes, thank you.
Great. I'll take it out.
Thanks. Doris?
Yeah, I would support that, especially the MOPS people would probably be the best group to also ask the question, especially about multicast. And a lot of the IPTV systems have been multicast in the internet to serve customers at home, and have recently started to evolve to unicast. And so a lot of that obviously comes from operational perspective and unifying everything around the preference for VOD. But kind of asking the questions if people have looked into the energy stuff, or if not, then offer them to collaborate on trying to make that analysis, right, in terms of comparing just the amount of equipment on both sides required and what their rough energy consumption is, right? So maybe you'll find people interested there. So
that would be really useful. So Simon Jones, who was formerly the chief architect of BT of IPTV for BT, is running that lesser called project, and I'll definitely steer him towards the MOPS group. I think we're looking for more operators to just help us review network, review the key elemental scaling points, to look for some of the steps, to look for some of those kind of key issues, and understand and get that picture.
Are you coming to Brisbane?
I'm not currently coming to Brisbane. No, sounds like fun.
No, it's just that the IETF MOPS or so is just the best that we have in our context. But in general, I think you'd find a lot more of these operator that you could ask at RIPE or NANOC, or even the NIC in Brisbane, right? So that which we've been invited to visit, right? So I think you really need to think beyond the IETF to really get to the core of operations.
Yeah, no, that'd be fantastic. I'll make a note of that for Ben.
Yeah, it's fun for MOPS and also this operator forums. Dom, I guess you're in the North American continent, so NANOC would be a good
UK actually.
Oh, okay,
but I know the name of the group. So,
so that's a really good point there. I liked a lot in this talk that you had. Good questions. I don't think we have answers for all of them. Also good suggestions, like just yeah, looking at the bottom line of large operators, energy consumption is a good start. But in the IETF style, of course, want to dwell into the technical details of some hobby horse topics like multicast, and you mentioned that I guess maybe as an example of something that wasn't deployed, and how do we deploy some other things that relate to sustainability if that wasn't deployed. Well, I think the demands and demand and costs are different for different types of proposals or technologies. So it might be the case that something that's actually really beneficial for the society is gonna get done sooner. Beneficial for the society and businesses is gonna get done sooner than something that isn't as beneficial. And I think there's reason for optimism actually, because from what I understand, the large network operators and vendors and everybody in the ecosystem is actually under a lot of pressure to make things better, and monetary pressure to begin with. If we forget the planet for a moment, then I think there's reason for optimism for deploying more things as long as we have those new things. So
I think I sort of touched on this issue in the presentation, but I think one of the most complex things is this decision about whether to sell spare capacity or turn it off. And I think that's counterintuitive to the business model of networks. Historically, they've traditionally built out capacity and then run to fill it, and then wanted to build out more because that's a growing telco business. And actually, we need to work out how to make the value proposition working smarter rather than working bigger. And that's a challenge.
And also, one more thing on this multicast angle, that it has some society level things and some technical things going against it a little bit. The society level things is that we are not all watching the same TV channel anymore. That's one thing. But then there's technical stuff like some types of networks are. It's no longer as easy to imagine that everybody's sort of getting the same packet through some massive, very wide area distribution, but you have like beamforming that goes 200 meters exactly to where you are, and in the same beam there are not going to be other users necessarily that can benefit from the same transmission. So
I think Johnny, just to touch on that multicast point. So a lot of background baseload traffic is video on demand. It's time shifted, people doing what they want when they want to watch it. But the really big spiky traffic is live events, and if a big live event happens on the internet at the same time as a big Microsoft update or a big, a big EA Games update, then everything hits the ceiling. And
that's a good point.
Though it's not just about everyone watching TV, you can pre-position content for a big premiere launch at 9 p.m. on a Friday and stuff. There's lots of ways that you can use multicast to take those very big spikes off the link, and I think it's very important to keep it on the map for that reason. It's having a resurgence. Multicast ABR has solved the problem that you can't play streams in the client with multicast, but multicast ABR kind of shims that out of the way quite effectively, and the industry is really catching. Certainly from my perspective in the streaming and CDN industry, that's really catching on, and I think that's going to be, media over quick, and a reintroduction of multicast in the core is going to be quite evident over the next few years.
Cool, thank you.
Thanks, Harry. I think also a little other problem is, Dom, in some accesses, right? The multicast is necessarily not more efficient, energy efficient for sure, right? Like if you take like Wi-Fi, like in like some of the stuff, the multicast transmits at a much lower bit rate, so the radio is on for longer, right? So it's not always clear that multicast gives you better energy.
I don't know why the multicast has any correlation to bit rate.
It's because it's unreliable, so the stations and the low rate, so the radio is on for longer. I think
so the good bit drops, but throughput's probably the same.
We can probably discuss it a little bit more. So I don't think it's like a slam dunk that it's better energy efficient. device, but we can
No,
certainly
no,
discuss
no,
it.
no. Yeah, and you have to in the model of multicast ABR, you have to effectively put some compute all over the network before you can offer the multicast. So we need to go and get those quantities out there. One thing I would highlight though is that unicast and multicast have always stood in two corners of a boxing ring for no particular reason. They and peer-to-peer should all be part of the menu of choices that operators have. And if we really move to software-defined networking and properly defined, properly distributed network functions, then we should be able to elastically go, actually, this traffic profile's changed. I'm going to move it midstream from unicast to multicast and make that sort of information on the fly. Again, without energy, real-time energy data, though, we'd be guessing. So
Yeah,
it's funny.
Perfect. Thank you. Tolas?
Yeah, maybe the other big area that has, I think, severely been underexplored is kind of the efficiency gain with multicast through pre-provisioning, right? In terms of where you're distributing stuff, and that happens in the background, like with the software or even the newest VOD stuff. This was all kind of, on the IPTV side, because all the operators just love the model of having more control by having network-based PVRs, right? So that storing things on the disk in the consumer home wasn't seen as something that allows you to make more money, right? So another one of those, as Yari, I think, nicely put it, societal problems in this case, more like more greed from the providers, as opposed to, because we had these disks at home starting with TiVo in 2002, right? So I mean, the model was working very nicely, but then the business model shifted.
I think I'm going to sort of come back on that with something which looks at the other end of the sort of delivery chain, at the content encoding end of it. But I think it's parallel. So basically, we should be moving to a world where we can readily move function to data and move function to the compute that's most appropriate, it's sort of energy efficient. And we talk about that a lot, but we don't really do it yet. A really nice project that we're sort of hopefully piloting over this year is we discovered a lot of windmills, when the wind blows, they produce maybe 200% of the energy they can actually shift onto the grid into the data center. So there's a lot of energy burnt off. They try to store some in batteries, but essentially there's a lot of wasted renewable energy, but with no guaranteed sort of availability. However, when we sort of took a deep look at some of the big data payloads that get processed in compute, not many of them are actually time critical. Video transcoding is rarely time critical other than in the live situation. Likewise, AI training, crypto mining, these things are not typically time critical. So if you could move those workloads to the wind power and process them in the windmill, we figure we might end up being able to use unusable wasted renewable energy and move some of that compute workload challenge out of the data center into the windmill. So again, if anyone's interested in getting involved with that project, do come and talk. We're starting to dig out a feasibility plan, and we've got some funding for it as well. So I'm interested to talk to any operators who'd be curious to try and come and play with that model. But it sort of speaks to the PVR model a little bit as well, because you're moving your encoding, in theory, you're moving your storage or your encoding process around in order to localize it to ideally more efficient energy. And that was just I think a fun story to talk about the other end of that process.
Thanks, Tom. Thank you. And thanks for presenting. Sasan, you're up next. I'll just throw up the slides.
Hi.
Hey.
So how can I control the slides? Sorry.
You just press right arrow, left arrow, you have control of the slides.
Okay. Now I see it.
Yeah.
Yes. Thank you.
Thank you.
So hello everyone. I'm Sausan. I'm a second-year PhD student at the University of Oxford. I will present to you my work about exploring the benefits of carbon-aware routing, which is a joint work with Paul Gunning from British Telecom, BT, and my supervisor, Noah Zilberman. So looking at the carbon footprint of the ICT, many tend to underestimate the impact of networking versus data centers. This is because a large hyperscaler can consume like 10 to 20 terawatt hour per year, whereas a large ISP already reports like 3 to 6 terawatt hour per year. But actually, there are many more ISPs, and this will just add up. So the carbon emissions of the network are not negligible. This work is basically about the networking layer, routing, and it specifically addresses scope 2 emissions associated with routers. So previous works focused on power efficiency, whereas carbon efficiency is something new. For example, if we want to send a packet from router A to router E, there are different paths, but different routers that are located at different regions will have a different carbon intensity. And consequently, for example, in this case, it might be better to route through the upper path instead of the lower one. So now these are different. And because this carbon intensity is predictable per region, then we can take benefit of this information, integrate it into routing, and see how much can we really reduce in carbon emissions. So the first step is really to define the carbon footprint of those routers. It basically depends on the amount of energy consumed, on the source of this energy, and the weighted carbon emissions associated with this source. And the last two terms are actually carbon intensity. So I will just define these two before going into the metrics, defining the metrics. So the model that we assumed for the router is having an idle power and then a dynamic power that is proportional with the utilization. And then this idle power can be further reduced into static power plus the power to enable every port. The carbon intensity, we all know it. One thing to note is that it really varies a lot per day, per season, per region. Like one might say in the UK that Scotland is always greener than other regions, but it's not the case. So the carbon intensity varies a lot. And because of new machine learning algorithms, the carbon intensity can be forecasted up to 24 or 48 hours ahead of time. So this is enough time for planning. So now that we know the carbon footprint depends on energy and carbon, then we defined a set of metrics that we integrated into routing. We have energy-related metrics and carbon-related metrics. The first energy metric is the typical power of a router, which is power at 50% utilization, and we extracted it from available datasheets. The second one is the energy rating of a router. Now, this is not standardized, but we started with a definition as being the ratio of typical power and the maximum packet rate. We collected information of available routers in the market, the ones that are providing their power values, and we could derive a range from 0 to 1, and we divided it into a 7-star scale. So this is like one suggestion for the energy rating. And then the next metric is the dynamic power per unit of traffic, which is like similar to the energy rating, but for this one, we only look at the dynamic power and we divide it by the maximum capacity. So that's it for the energy-related metrics. For carbon-related metrics, we of course have the carbon intensity, and then we can also have the carbon emissions of the previous interval of time. So it's just the product of energy consumption and carbon intensity. And we also considered some combinations of these metrics, for example, having carbon intensity combined with energy rating of routers. So what we did is we took these metrics and we integrated them into two approaches. The first one is a very straightforward one, just change the link costs based on these metrics. So for example, here we can have these two paths that have the same cost. Like with ECMP, we can route through these two paths. But if we add like the energy rating into these link costs, then we would have a different distribution. The second approach is a carbon-aware traffic engineering one. So the first approach has only an impact on the dynamic power because everything is still on. But the second approach will also try to further reduce the idle part by shutting down underutilized links. So Kate, carbon-aware traffic engineering, is a heuristic that shuts down links with least utilization and highest carbon emissions. It checks then if the graph is still connected with some redundancy margin, and then checks the improvement in terms of carbon emissions, and then does this loop over and over until no more links can be disabled. So this is a simulation-based study using the NS3 simulator. We applied it on two real network topologies, which are British Telecom, BT in the UK, and on Giant, which is based in Europe. So before proceeding to the results, the traffic patterns that we considered are also important. We have day traffic and evening traffic patterns. For day traffic, it's mostly dominated by business customers, and it's mostly symmetric, like from any node to any node. There is no special pattern for this, and the throughput is almost constant. Whereas for evening traffic, residential customer traffic dominates, and it's mostly downstreaming of content from caches, and it peaks like between 7 and 8 p.m. So if we look at the BT network topology, we can see core nodes, metro nodes, and tier 1 nodes. According to BT, their caches are located at metro nodes. So the traffic here is mainly from these metro nodes to all other nodes in the system. So in terms of results, now really the animation is missing in these slides, but it's fine. First of all, if we look at the energy-related metrics, which are P-typical, E-labeling, and incremental dynamic power, we can see that the incremental dynamic power has the highest improvement, but it is minimal. But then if we combine them with carbon intensity, we can see a slightly higher improvement in carbon. And then Kate, which further shuts down unnecessary links, we see like an improvement of up to 15% in carbon savings. Now, of course, you notice that some have negative energy savings, and this is because the optimization here is for carbon. So we might be consuming more energy, but this energy is actually greener. And then this is for day traffic, whereas for evening traffic, we can see that savings are really small, and this is because flows for the downstreaming pattern are mostly short flows, and it's very hard to reroute the flows within the topology. So the savings are really small for this. If we go to, so that was for BT. For Giant, we assume that all the nodes have the same characteristics. So that's why here we compare only between carbon emissions, carbon intensity, and Kate. We see similar things like up to 9.5 or 10% improvement in carbon. Now, in terms of delay, carbon-aware routing doesn't have like a big impact on the delay. You can see here that they're just similar. Now, if we want to see how the flow intensity is changing between regions, this is for BT, which is based in UK. On the left, we can see the carbon intensity per region in the UK, and the values here are extracted from the carbon intensity API, which is a public website. And on the left, we can see the flow intensity in gigabits per second per region. So if we start by looking at Northwest England and East England, regions 3 and 10, we can see that these are like relatively greener regions from the surrounding. And we can see that with OSPF, from OSPF to carbon-aware routing, the flows are increasing for these regions. Whereas if we look at East Midlands and South England, we can see that these are less green, and consequently the flow intensity are smaller with carbon-aware routing, whereas London, you can see that it's just like the same flow intensity with OSPF or with carbon-aware routing. And this is because a lot of nodes are actually placed in London. So London is somehow a bottleneck in this topology. Now, if we look at Geant, we have something similar. So if we look at the top countries that have flows in them, we have France, Italy, and Germany. So if we compare OSPF and Kate, we can see that France had like 191 and then it had 282 gigabits per second. So flow intensity increased, similar to Italy. But for Germany, we can see that this flow intensity decreased, but yet it is still very big. And this is because Germany is actually at the center of the topology. So it's also like acting as a bottleneck. So a final aspect of this research was to look at the impact of static to dynamic ratio of routers, because different routers will have different ratios of this of static and dynamic power. For example, chassis-based routers have a very high static power for the chassis. So we changed this ratio, and we can see that as the ratio increases, which means static is higher than the dynamic part, the carbon savings are also decreasing a lot. So it's always better to invest in replacing equipment with lower static power routers. So in summary, in terms of metrics, we can see that carbon intensity combined with the incremental dynamic power are the best combination of metrics. So mainly carbon intensity with the dynamic power. For energy labels, these are really like a good idea to have for the router. They're good for purchasing, but maybe have limited routing benefits in this form. We mainly recommend not to combine static and dynamic power into one metric, because then we will have inaccuracies. Third, we have the issue of high idle power that limits carbon savings. We have routing bottlenecks that also limit carbon savings. And finally, the carbon optimization is application specific, because as we've seen for downstreaming, carbon aware routing doesn't work much. So next steps, we need to really identify and agree on a set of metrics. We need to establish veracity of reported metrics, which is mainly have trustable sources. Like we have these carbon intensity values that are publicly available, but can we trust them? And what we did is only for one autonomous system. What about inter-domain routing? We need to define standard reporting formats. And finally, it's very interesting to have to tie electricity consumption and carbon intensity to applications, so that, which is the concept of carbon tracing, so that ISPs or companies can really know maybe identify ways on how to reduce their carbon emissions, and maybe also give users some options on how to reduce their carbon emissions. So this work was published in Conext, and the code is available on GitHub. And thank you.
Thank you very much, Sasan. Very, very interesting. And do you have any thoughts about some follow-up work at IETF or IETF for this?
Well, we have the TVR working group, so this might really align with what they're doing and really follow up on the formatting of the reported metrics.
Okay, perfect. Thank you. Thanks. Ali?
Thanks very much, Sasan. Great work and great presentation. One question I have is, out of your research and experimentation, can you make suggestions on architecture, network design, how it can be, let's say, changed to enable better carbon-aware routing outcomes? like you said, London or Germany were the bottlenecks, so things didn't change much. What would make carbon-aware routing more successful from an architecture and implementation perspective?
Yeah, the main thing is the main thing is about static versus dynamic power, which is about the vendors. But for the design of the topology now, the problem is that we already have all the sites there. We cannot change their location, but we can also maybe, because we know that these are bottlenecks, then increase the energy sources that are like green energy sources in these regions. And of course, whenever we design new things, then sustainability should be in our heads.
Yep, sure. And one small comment, you started by saying scope 2 emissions. Usually scopes are defined for organizations. And when you say you're using scope 2, you're meaning purchased energy, right? An organization purchases the energy. When you are saying that for experiment like this, what specifically are you meaning when you say scope 2 is targeted?
It's basically the electricity that is directly used. It's not the one that is embodied, for example, or the one that is used for the recycling later on. No, it is the one directly used.
Yeah,
that
so
they are paying for now. Yeah.
So that can be defined differently for which perspective you're looking. Scope 2 of the manufacturer or scope 2 of the operator. So it's that kind of...
it's the operator. Yeah.
Okay, thanks.
Thank you.
Vesna, you should go ahead.
Oh, yes. Hi, thank you for your presentation. I wanted to say that I think this would be very interesting for the network operators within the RIBE community and other network operators groups. So I wanted to invite you to come and give a similar talk to the RIBE audience. And I also was thinking ahead, like if and when this becomes more accepted, I think it would be good to register that information in the peering DB. Did you already consider that?
Sorry, what is it?
So there is this database called peering DB, where a lot of networks register their routing policies and their location and so on. So I think the characteristics of either regions or networks or routers could be registered there, like the carbon intensity that you're measuring. It could be possible to add that to the peering DB, because this is where the operators actually look for the other information about their transit providers, peers, and so on.
Okay, so the thing is that this information is already public, the one that is about carbon intensity. There's like electricity maps, and there's this one that is based in the UK. So it's not like only for the operator. It's not like for their sites. It's basically for the region, for the whole region. So this is like also like a limitation here, because we don't have the actual data for every site in the for the BT network, for example.
Okay, thanks. I will follow up with you on this if you don't mind.
Okay. Yes, thank you.
Thank you.
Thanks a lot, Sasan, for making time for us, and really interesting research. And thanks, Noah, as well, for pointing out Sasan to me. So thank you.
Thank you.
Thanks. I think that was the last scheduled presentation. So Yari and I have some thoughts written up for the next steps, and I will go off video, and Yari will start talking about it. And feel free to chime in. So we want this to be a group exercise, and not just us. So talk. Thanks.
Yeah. Thank you, Suresh. Yeah, so we had listed next steps as the last agenda item, and what would be interesting for us to think about is, and Suresh, if you can go to the previous slide, that's first. It would be interesting for us to think about like what topics or work items we have in this group or program, and then think about like what are the next steps for each of them. And so Suresh and I collected this. We might have missed something, so we can certainly keep editing this. So please contribute misses or extra ones that we shouldn't have there. But basically, we have some work on metrics. We have some work on this sustainability considerations. We didn't talk about that too much, but I see that there's like this possibility or maybe a need to educate the IETF. We talked about the benchmarking methodology and maybe some standardization of the scenarios as well associated with that. We talked about carbon aware routing. That was super cool and interesting, by the way. Thank you for that. We talked a bit about open source. We've talked about engagement with policymakers, and also there's a question of like what are the venues for some of these things. So if you remember the overall plan of this program is not that we do, the IETF's technical work for the IETF. It is for the working groups to decide what metrics they want to actually standardize. But for each of these things, either it's we will publish some document that considerations might be a document from this group, but a definition of metric is some working group. And for each of these things, we might want to know what that venue is, where to do that exercise to the end. And now, Suresh, if you go to the next one. So this is some early thoughts from us, what this might actually mean. So starting with metrics, the overall idea is that we need to push through the metrics work through the working groups. And then there's more detail, of course. I think it would be really good to start with the simple metrics and not try to boil the ocean and cover every case, make something that's extendable for later and then extend later. But we do have to resolve some issues. I think for me at least, the bigger things are about these transports, like where do we want to transport this information in, and also whether it's like we're doing our standalone thing or it's part of some bigger framework, that there's some description of devices and networks and we embed some sustainability information in there, or we do our own thing. And of course, it's probably not the case that we have only a single answer. There might be multiple transports. We need to have some idea to decide whether we should go forward with, say, the ICMP stuff or not. There's some more detailed stuff that we should probably resolve. I won't go into that right now. I think we'll need to help here. So typically you have the situation that there's a broader interest like sustainability in this case. But then if you go to a particular working group, there's only a couple of people that are particularly interested about sustainability. And then there's other people who may have other goals, like they need to do their specific development that they've been working on. So it's important that we are part of that. I think it applies to all of us. So please attend the benchmarking methodology and IDI and other working group meetings when you can, and voice your opinion as well. But there is some legwork to be done before we are there. Considerations document, tentative answer. We should probably shoot for an RFC coming out of this group. The venue would be here, but not before we've done some downscoping and, of course, more review. But starting with not trying to have a super lengthy document, but focus on a part of it that we discussed yesterday. And if we want to publish something from this program, then the IAB needs to be okay with that. I'm not a member of the IAB, Suresh is, and there's some other people on the call, I think, who are members, but even they cannot necessarily say that, yeah, that's okay or not okay. We need to present them with a document that's a little bit more ready, and then we can see whether that's feasible. Education, I think that would be super cool. So some of the presentations that we had today, for instance, would be really nice to have a little bit more broadly for people whose main concern is perhaps not sustainability, but yeah, tweaking security or improving security or some such. So how do we do that? And there's some options there. I guess for the benchmarking stuff, it's the BMWG. That is the place. Yeah, some question marks also there. And carbon aware routing. I really like this Vesna's suggestion that's the talk we just had is, we're really cool to have in RIPE as well. But otherwise, is there something that we need to standardize? Is there a thing that we should discuss in our IETF working group? So that's a question mark. And then open source, obviously, more hackathon projects, but exactly what? Open question. Whether there's tooling for measurements, like we talked about today, about the software stuff. Another open question. We need people to drive these things, of course. It doesn't happen just because we say something in a meeting. Somebody needs to invest real time on that. Engagement policymakers, we talked about getting together with ISOC and IAB and see if we can get ISOC energized to work more on the sustainability angles for the internet and for the benefit of anything that uses the internet. And then the question of venues. I mean, some of the venues were listed here, but maybe there are other things that we didn't mention that don't have a venue at the moment. So that's the summary from my side. Suresh, did you want to add something?
Pretty much all the stuff. I think the venue thing, I wanted to have a different angle into it as well, is that there's like work that needs to get done but doesn't have a home yet, right? Like, so is there a need for a BOF or a proposed RG? So that's also something I think we can talk about a little bit later, because I know like Brian could not make it here, like Brian Trammell, but he did have some ideas for some operational measurements that may not have a good home yet, right? And that could like lead to a BOF or like a proposed RG at some point. So like that was kind of the only thing I wanted to add, but everything else is covered. Yeah, thanks. So now we open up the floor, any thoughts from your side? Should we keep doing this? Did you find this interesting? That'll be like really good to know as a first order item. Yeah, thanks. Go ahead.
Thank you. Yeah, to answer your last question first, I definitely find it very interesting, especially the parts where we are talking about the sort of more high-level things. Some of these presentations are sort of overlapping a little bit with working group work, and I think that fits better in the working groups, because when you're getting concrete, we should define RFCs and all these things in the working groups. But this I was into this backcasting thing yesterday. We're trying to identify what are the sort of things that we need to do in order to progress. That's a perfect thing to do in these settings, I think. And for example, this benchmarking and how the video works, all of these sort of high-level things that makes us see what pieces are missing. I think that's perfect to do here. Then a comment on your previous slide, Suresh, with the metrics and all of these things. So I think we should break that down into I mean, that's the most concrete part of what we do here. It's the metrics. That's where we are closest to actually touching something. And we should divide that into two pieces. We have the metrics for devices, and we have metrics collection and the controllers and all these things that are trying to act on these things. We should separate those things, I think, or at least identify that this goes on the device and this goes on the controller side.
Yeah, we also have multiple drafts in that space. We should actually divide that list also according to that. And some are like abstract things, and some are actual metric definition. So there's actually a lot to unpack there.
Absolutely.
I agree.
And my thinking is that while it's very nice that we have this device-centric work going on, we can't wait the years A to standardize and B for that to be deployed in actual networks. So we have to work on controllers side that can work with whatever is out there now, so we can at least get started. And then after 5 or 10 years, when this is out and actually deployed in networks, all the nice things that we did for the devices, then we should of course be fitting that in too. But we have to work in parallel tracks for that. I think I already talked about this backcasting thing, but that's another thing I would very much like to do here. Can we sit and discuss what is missing in a more focused way, sort of a workshop way? That's something I would really like to do. And my last question, when it comes to these open source projects and similar things, is there any possibility to get some sort of funding? I mean, I don't mean for hours perhaps, but at least to run some web servers or this sort of thing. That's what I have.
Yeah, thanks, Jan. So just to address like one thing, right? Like the reason for having the drafts here is that people kind of get like a bigger view of the things, because I think I think like all the working groups need to have a sustainability angle into them, right? At some point, but it's not possible for like everybody to go everywhere. So this would be a place where people can exchange ideas and know about things that they don't know about because they don't necessarily follow. I would think like, the model is very similar to Carsten is like still on the call, I think, right? For the IoT folks, right? Like the IoT working groups, related working groups are all over the IETF. So it's like, it was very difficult to figure out like what was happening. So we set up an IoT directorate in the int area like to do it, but Carsten also has his like own effort, like, where he tries to tie this all together, like what is the work that goes on in all the places, and he kind of comes up with the IoT calendar kind of thing. So there's like a really cool idea that like, people working in a specific space that's not an area to kind of collect like or collectively know the efforts that are ongoing in the area. That is really the goal, not to take work away from the working groups and not to slow it down. Right, that was like the way the program is written this way, the description is done this way, because that was an explicit concern from some of the IESG that this would take away the focus on the work, right? Like, if you have this here and it takes longer, right? So the idea would be to kind of let the working groups proceed, but also identify if there's gaps and maybe there's new working groups needed or not, right? Like that is like the part of it. And yeah, like I would love to kind of continue on this, and if there's another workshop needed, we can certainly talk about it. It's like certainly in our like description to kind of like go and do it, but I think it's a bit too early like to like do a workshop without knowing the actual topics that are going to be interesting for that. But it's certainly something that like it's specifically written in our program description that we can do it like once we know what we need to do. Yari, did you want to add anything?
Yeah, I think, Jan, you might have been asking for like not like a workshop, but like a session, perhaps a little bit like today's interim meeting, where we would focus on the backcasting, and that I think we could do, right, Suresh?
Yeah, for sure. Yeah, so we can spin up another interim with like, if you know a topic, right? Like for this is one of them, and there's like a lot of interesting topics that came up that have interest from people, but like not like critical interest, right? Like, so these two things the Yari and I thought like, had I would say the biggest like widest interest in it, right? Like, but I'm sure like, there's like smaller sets of people. We can run another interim soon to go about it. Yeah, thanks. Yeah, Vesna, go ahead.
Yes, RIPE NCC has a budget for hackathons. So if you would want to co-organize a workshop hackathon on these subjects, we can contribute the organizational skills of actually making an event, and we do have a budget for this year for that. So let's pick it up on the mailing list.
Awesome. Thank you, Vesna.
Great, thank you.
Thanks. Tolis?
And maybe just logistics-wise, maybe similar to how we're doing this in some, I think, of the directorates. So just have one of the wiki pages where the different documents that are considering themselves to be part of the effort can basically be listed, and then you do a call, let's say before every IETF or so, and say, please do an update. What has happened on this draft since the last call, right? Because at some point in time, we just want to do a broader, effort tracking, and I think that's the best way, right? Whether it's whatever working group it is, it would be lovely to have these updates, and it can all be self-maintained by the people. You need to just start that wiki page so that the people can start contributing their update status.
Sounds good, Tolas. Like I did have a different suggestion yesterday, right? Like I thought of like putting this in the data tracker in the documents, but like yours sounds better. So like we
No, I mean it's two levels, right? So just having the list, putting it as associate into data tracker, I think is just necessary because people start looking into data tracker, and even having people find a wiki page is another challenge, right? Maybe there is in the program is there even a field to point to a wiki page?
I think there's like I think there's a related links. We can probably put one there. So, but I can like chat with Cindy for like an IAB that we can actually throw.
I'll just try to dig up the page on it's working group updates and not document updates. But so in the IoT directorate, they always call us before every IETF to summarize updates, and I think we can simply ask the people who have an e-impact related draft to do it for the drafts on that wiki page. So I think that would help us then after a year or so, then at least we have three updates, once before every IETF or something.
Sounds good. Excellent idea, Tolas. Thank you. Thanks. Ali?
Thanks very much. This was really helpful and useful, so I fully agree we should do more. One question I have is about the timescales of the next steps. Like, can we put a level of urgency or time scope? What we should do right away? Of course, developing the drafts and proposed RFCs, but more specifically, what to ask from IRTF or what to forward to IRTF? Do we have we identified longer term things that can be handled in IRTF, or is that even the criteria, like long term questions IRTF handles, shorter term we handle? What's your view on that time scope and research focus?
Yeah, I think like by we, if you mean IETF, the answer is yes, right? Like, so the idea is like, stuff that's ready for engineering goes to IETF and IRTF. But here, like, we are kind of doing a dispatch function. If like, if we can think of it that way, we look at stuff and say, hey, is this ready for engineering? Is it ready, like, some kind of research? But I think it finally goes to Colin, right? Like, so again, it's the same process. If there's like existing, like, Alex has like a draft in NMRG, right? Like, he talked about it a little bit, right? And also Sasan's work can fit in probably somewhere in like IRTF. I'm not sure exactly where at this point, but it also has like IETF implications, right? Like in TVR. So like it's going to be on a case by case basis, but the program itself is not going and telling people what to do, right? Like the people participate in the program and also do the stuff on the side. So I think hard for us, like, but there are some actions the program can do, like, the policymaker engagement and probably the education stuff that we can certainly do. And I would say utmost urgency, I would say, like, as soon as possible, like for Gary.
Okay, thanks.
Thank you. Thanks. Give it a minute to see if somebody else wants to speak up. Okay. I think that was like extremely good. So thank you very much for everybody for like presenting and participating and all the side chats. Like really enjoyed them. I hope the side chats are saved. I just opened up a lot of the links to kind of save them, but feel free to send them to the list as well. And specifically some of the stuff you sent is like very interesting. So I would love to see them on the list, right? Like, I saw, but I saw you sent out or your report from that. I would love to see that on the list if you can. I just took a quick glance. Thank you.
Will the chat be saved? Is the chat going to be saved by you or the system? Or
I said it personally myself, right? I'm not sure if it's going to be part of procedure.
thank you.
It's saved in the data tracker.
Okay, cool. Thank you, Carsten.
Yep. Thanks very much indeed. Yep.
I took some notes during this last part of the discussion on the next steps, and I think we will do another update, perhaps in wiki format or some other format of the next steps for each individual thing together with Suresh, and then we can discuss that on the list as well.
Perfect. Thank you. And I did also take some notes, like to have like some minutes, so we'll put that into the proceedings as well. Thank you. Emil, did you want to say something?
Is our next meeting a program meeting in Brisbane? Is that the plan? Next time E-Impact meets?
I think we can discuss it, right? Like, but probably it's going to be another interim. So the idea was to have a IETF hybrid meeting every year. I think it's like what in the beginning. So I would assume like, we would have one like probably end of this year at an IETF meeting, but continue to do interims.
Okay, wonderful. Thanks.
Yari, like, do you think we have like reason to meet in Brisbane, like after this?
Well, to begin with, if we meet in Brisbane, it's going to be a hybrid / virtual meeting. I think it's going to be less people than in other sites, most likely. But I don't think the question is, are we meeting in Brisbane? The question is like, what's the useful next thing for us to do? And then we do it whenever. If we come up with that plan in the next month, then we can have something during Brisbane and people calling in if they're not on site. If that's a little bit later, then we do an interim in the spring.
Yeah, sounds good, Yari. Thanks.
Thanks.
Douglas?
Yeah, I mean, if there is no clear program-based work item in Brisbane, we can still kind of say just informal coffee, kind of just somebody puts it in for whatever site meeting room around a coffee or so. Just there are probably some draft authors that want to have mutual feedback or so. Just nothing official, but you come up first if you have a program plan, and then we do that fallback.
Sounds good. Thank you. Thanks. No, thank you very much, everybody. And I know it's like a Friday evening in Europe, so thank you very much for taking time from your weekend. And we picked this time because it collided with nothing, but we did find out there's a collision that happened afterwards. Somebody didn't think of us, so for the IEEE IETF cohort. So thank you very much for everybody to attend, and please stay active on the list.
Thanks a lot. Super interesting stuff. So let's keep working on it.
Thanks very much to you. Have a good weekend.
Thank you, Suresh and Yari. You're giving me hope.
Bye.
Bye.
Bye.